to look at word problems that help us understand the importance of an equal sign a little bit more. So to start off, we have our first word problem that reads, Caleb has 10 pairs of shoes. He received more shoes for Christmas. If he now has 20 pairs, how many did he receive? So our first step is going to be to figure out what kind of word problem this is. So first we're going to look at the problem and see if there is any change in the problem. Caleb has 10 pairs of shoes. He received more shoes for Christmas. So therefore that is telling us that there is change in the problem. So it is either a join or a separate problem. Let's keep reading to find out which one. If he now has 20 pairs, how many did he receive? So he is adding more shoes to his collection. Therefore, it is going to be a join problem. Now, we're used to looking at word problems or equations that look like 10 plus 5 equals what? Well, today we're going to look at problems that look a little bit more like blank plus 5 equals 15. So to start off, we're going to use our first problem, which is a join problem, and we are going to use a set model to figure this out. So in our set model, we will have our start, our change, and our result. It's important that we look at this as a balance. So we have from our word problem, we know that our start is 10. So we are going to model that with our base 10s from our previous unit. So we have 10, which we know that one of these rods equals 10. So we put that there. He received more shoes for Christmas. So that's our change. That is still unknown. So we're going to leave that blank. If he now has 20 pairs, how many did he receive? So our result is 20. So we'll also model that with base 10, which would be 10 and 10. Gives us 20. So looking at this, we know that this is not balanced right now. So we're going to have to make this balanced in order to find the answer to our problem. So what we're going to do is we are going to count in our change area. We're going to start with 10 and we're going to count all the way till we get to 20, and that's going to be our change. So we'll start with 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 units, which we know we can just swap for along, right? So now 10 plus 10 does equal 20. So these are now balanced, and that gives us our change, which completes our problem. 10 plus 10 equals 20. So now we're going to model it with another word problem. This one reads, Sam has some apples. She gave 4 away. She now has 6 apples left. How many apples did Sam have to begin with? So we're going to first remember to look at the problem and figure out what kind of problem is this. So remember, if we're trying to determine between join, separate, compare, or part, whole, we need to see if there's any change in the problem. Sam had some apples. She gave 4 away. She now has 6 left. So looking at that, do you guys see change in the problem? Good job. Yes, there is change. Now, to determine whether it is join or separate, we need to figure out whether we are subtracting or adding. And it says that she gave 4 away, which means we are subtracting. So that means it's going to be a separate problem. Now we're going to model this using a linear model. Okay, so this is like saying start minus change is result. Now to plug in our numbers, we don't know our start. We do know our change though, which is good, 4. And then our result is 6. So this is going to be our start, which is unknown. Now we do know our change, which is 4. So this will model our change. And we also know our result, which is 6. So we're just going to add this way still, all the way till we get to the end of our start. And this is our result. Now, as you can see, the result and the change added together equal our start. So that means all we need to do to find our start is to add our result and our change. So 6 plus 4 we know is, good job, 10. So all we need to do now is plug it into our problem. We know our start is 10. Now let's check. 10 minus 4 equals 6. Is that correct? Good job. And that is how we solve addition, subtraction problems using linear and set models. This is important for us to remember that equal signs not always look like, equations don't always look like this. Sometimes they look like this. Sometimes they look like this. And that's okay, because now we know how to solve them.